Hello, my name is Dmitry Savintsev. I work for Yahoo, I work for the Paranoids, for the security team. I've been on Yahoo for a long, long time, actually since the beginning of the century. Been doing the engineering, so the just development of billing systems, infrastructure, and in the last years got in the security team. And my programming kind of biography follows the track of both industry and Yahoo development. So when I came, we've been still doing web application in C++ with all the Apache handlers, and then lots of Perl, PHP, Python, Node.js, and in the last months been doing Go. So this talk about some web application security in Go. Web application security, I haven't heard a lot of information or experiences about using Go in the security space. So there are some programs, like for example for encryption that uses, but traditionally is web application security. People use a lot of Python, Ruby, and also Java. Some scanners are written in Java. So I would like to hope to change this and get a little bit more Go, because I think it's a great language for the security. So I will talk about the components of the scanner, or what need not the whole thing, because it's the work in progress, but some of the pieces that I was able to pick out. So the WebSec Lab is a kind of a toolkit for making the test, or for creating test for the scanner. Then the context detect, that's a piece of the scanner that we've been running for the last months with good results, and talk about some the CD and the next plans. So about the web application security domain, this, I think it has two parts. One is it's like a specialized QA, so you're doing a lot of checks. So there's websites or there's products, and you have to look for them very carefully with lots of attention to details, and trying to imagine all the perverse, bad ways, unexpected ways that your application can be used. But it's also enabling, like helping developers. So you're both a police and a kind of servant. So you're doing like a consulting and training and explaining, and for that work, the automation is paramount at scale when you have to do a lot. So you usually have a few guys and hundreds of thousands of developers. So the ratio of coders to paranoids is requires automation, and you also have to do a lot of tools. Tools are at the course, and what we've found out that you need custom tools. So it's not enough just to take something that's available on the market or in the open source. You end up making them, because also things change. You need to adapt. You have to create your own. So we run our own scanner. So my kind of specialty at Yahoo is maintaining and developing XSS scanner. So our part of the scanning system that is targeted at XSS and related things. And that's what takes a lot of time to create a scanner, and to be able to scan all the sites all the time. That's our purpose, our kind of dream, so that we scan all the production sites as well as all the sites that are coming from the CD pipeline, or fire hose, you can say. Well, I really got to like Go, and I could sign up if you've seen it, .go, Andrew's talk, why he liked Go. So it's a lot of things that I as well, starting from Go format. That was relevation. That's exactly, I think, how it should work. But especially for tools development, and not just for ops. So the advantage is that there's easy to deploy with static libraries. You don't have this dependency hell. There's usually less or runtime errors, undefined functions, undefined symbol. You have the whole build chain, so the compiler, dependencies are also written down, and the test facilities are right there. So it's when you have the test files, so you have like file, and then there's file underscore dot go. When they're uh, placed together, then it stimulates people to write good tests, or at least write some tests. And when you look at reviewing the code, if you see that there are no underscore test files, then there's something wrong. And especially for web security tools, advantages are that the great HTTP stack and the whole network, kind of the batteries included. Of course, concurrency and performance are important when you have to scan um, many thousands of sites and do it in reasonable time. What I like for the just general tools is that it's easy to make a web GUI. So usually you do a tool and do command line interface, but if you need, or if you prefer something nice or want to give a user something nice, it's almost trivial to put a wrapper around the functionality. And especially for the security tools, where I think Go has or provides a feature what I call abstraction elevator. So you could change the level of abstraction. You could normally program at a relatively high level, like almost like with the scripting languages. But if you need to go further, go down, so almost you could go all the way to the packet shifting, or to those network primitives and rewrite or modify them. So at times it comes. Well, so our first, I won't talk a lot about this, but kind of the first dip in the toes project was the dead link crawler. That was my learning project, or free time project. I thought about then kind of getting a feel whether it would be appropriate for a web security scanner eventually, and took a very simple task, just finding dead links. And when you have lots of sites, they come from periodically, and so it worked very well. It was able to plow through thousands of Yahoo sites. I made it specifically just for Yahoo.com and flew a couple of other domains like Flickr and Tumblr. It found a couple of dozens of bad links that then we fixed, something like maybe 2 clicks from the home pages. I would. It's hard to imagine how it can be found manually. So you need the scan tools, and when they fixed it, it's better user experience. And good, the colleagues were kind of excited. Some people told me, well, that's great job, and that's good when you're trying to introduce or start a bootstrap a new language at a corporation. It was running at like 100 stable concurrent jobs. I ran for a few hours before killing it, and the memory consumption kind of peaked around 3 gigabytes and then was slowly increasing because with the crawler like this, you have to keep a map of the visited links, and that it grows. But I was surprised that it was quite solid and stable and finding good stuff. So some of the lessons, beginner or rookie lessons, you find out fast that you need to close the body, otherwise it goes south. The U limit needs to be increased, and also I found that kind of the sweet spot is somewhere between 100 and 300 Go routines that go in parallel. Because when I try to do like 1,000, then I was getting DNS errors that could be set up of the local DNS server. So you can talk about the WebSec Lab. So the topic came up again when we were working on the security scanner, that, or in general on kind of working with security issues and trying helping people. We needed things so that we could put together tests quickly, or have a test suite for the scanner, so all the corner cases, because we cannot wait until this obscure bug will come next time. So you have to have it like all saved. And there were several iterations, not just myself and teammates. Usually we would do some kind of ad hoc PHP scripts. Then there was an application that was kind of a mimic of a small copy of Twitter, but with insecurity. And then I wrote WSEC Lab that was similar to what I showed, but in Node.js. But then when I discovered Go, I said that's the right thing, and that's what I want to use it. So I wrote a set of tests in Go. It is a site for testing web security scanners such as XSS scanners, and in that is similar to recently, I think the idea was in the air, Google open source firing range, so it's um, similar idea, but it's in Java. And I also think about this not just a site that has a few pages or that are vulnerable, but also a toolkit for constructing new tests, so that it's would be easy to, when you need to explore something or show or replicate, so that you could put a new test one. So and use it for replication of real use cases, like we have a bug bounty program. So and our or from the stage of production, when we find something, I try to put like a model or distilled a minimal version in WebSec Lab, so that I could keep it for the scanners. So the requirements are many cases are like a standard one. So you get an input, the input is not filtered or filtered incorrectly, and it goes into output. And so input with no own filtering. But the badness, so the output, it has to be tightly controlled. So we cannot just put a unfiltered output everywhere, because then it will trigger all the tests. So for the test isolation, they had to be separate. And some of the tests are special. So for example, the HTTP response splitting or referrer injection, they are not like other just bad input filtering. In Go, so there's a convention that the input comes as the in CGI variable, so that you keep it the same, and except the special cases, and there are filters that convert the input value. I'll show the code. And so there some of the convention that if it ends with .ok, then we turn off badness, and I'll show how it actually uses Go feature for this. And if it ends with underscore of p, then it's a false positive. That's another thing that you have to check a lot with the scanner. So if the scanner is too noisy, if it produces false positives, so false alarms when you do scanning at scale, it will kill the output. It will drown the signal in noise, and any users will just be put off by that. So it's you can think about this, realized when I've done this, it's special purpose web mini framework. So it's has a place where it picks up the templates. So it uses Go templates. But of course, it uses text template so that we could do the bad output. It has some library of filtering, and it has the filtering has standard blocks. So for example, tags off or on. So if it's tags off, then we filter all the tag characters, or double quotes on and off, so that whether it goes through or not. So here's the so for example, yeah, those codes. So first, when I was writing this, I was trying to do this all in functions, that just for each combination of this, I was doing like a count function, and I had function do quotes of with spaces, no tags, and it's kind of a combinatorial explosion. There was a lot of code duplication. So then I got this one, and I got based on this, there's a transform function that combines them and applies those filters in sequence, so that you could just specify a set of those and get the corresponding input filtering. And here's an example of custom processing that it doesn't come often, but there was a bug where the escape to the \x would be converted to the normal characters. So that's the function just undoes it. So this kind of a corner case. So we'll because this can be done for replicating badness. So where if we find a like bug or so internal thing, then we could just paste the template, set filters, and have a new case. And also, it allows to see the issue in the realistic setting. So if you grab the HTML from the production kind of scan, then we have a test with the real real HTML. But it also, what I really like about this, it can be used to resurrect badness. So for example, if it's from bug bounty program and there was an issue, our developers sometimes are very fast to fix it. So they fix it before I get to this or before I wake up. So earlier I had to ask them, could you please put the old vulnerable version on a test server so that I could check it with my scanner? And this was an awkward thing to do because developers have other more important things to do than put the old versions somewhere. So now we do this way. Our incident response team, when they triage those issues, they save the output and add it to the bug. And then even if it's fixed, I grab this dump, HTML dump, convert it to Wexip Lab test, and put it, then I can play it with it as much as I can. So, okay, so let's try demo. That's the page, so I put a bunch of those. So for example, the classic is the full JavaScript. It's like when there's no escaping, and we just put alert, and so it works. So or there's the post one. It's also special. So there's most of the case with get, because it's sufficient to check the output handling, but you need to check this as well. So if you, let's say you get image source equal full equal alert hacked script. So that's image. No. Yeah, you're right. You need to close this one. Yeah. Equal. Okay. So last tense. There are some cases, like for example, on mouse over. Let's check one of those. Or on mouse over. So we could take a look at so it's in the source, it's values in input. Okay. Anyway. Injection. On mouse over equal. See if this works. Oh. That's, it has to go here. X. Ah. Sorry. Alert. Alert. Ah, sorry. That's bad. let's try this one, the JavaScript injection. Put here. Yeah, so this injection in JavaScript, and we could see the source. This is in the JavaScript block. It puts this the injects the code that gets executed. So we want to open source this. So and I'll so okay. So it's now public, and there's a description in the README of the tests. Okay. I hope that it would be useful for the consultants and the people who not only to develop the scanners, but people who work with the doing pen testing, and they can copy or make the tests from the WebSec lab. Okay. The next piece that I want to talk is the context detect. So that's actually in the XSS scanner is the piece that responsible for the analysis of the output. So there's usually the scanners, they send some fuzzy string to the site. It returns output, and then you need to analyze it. So previously we had lots of regular expressions and the custom scripting. For example, and that got difficult to understand and quite fragile. And there were still lots of false positives and false negatives. Then we modified it to use Go, and we used HTML5 parser for analysis. So and it worked. So HTML5 parser has the tokenizer and the high level, the parser interface. We use the parser, and it defines or verifies the context of injections, and this way we can do different injections. They may be innocuous if they, for example, in the properly quoted string, or they can be bad, or can be dangerous in different contexts. We also use the JavaScript parser from Robert Kreeman to check whether injections breaks JavaScript or not. We've seen the example previously that was injection in JavaScript. So usually when you're sending the fuzzing script, you're not sending just some numbers or alert, but some special characters. And if it gets injected inside of JavaScript, it's usually breaks the block of the JavaScript and makes it unpassable. And by this detection, we can see if it's almost emulate the browser and see whether the injection will, and if it breaks JavaScript, then it's likely to be exploitable, because then you can put your own stuff, your own script. So you're kind of broken the sandbox. The normal kind of the rule that the input shouldn't leave the same context when being output. So here's how it's done. We have the function check JavaScript, We need to do some marking because of the comments, the browser, so we kind of imitate with replacing this, the comments, removing them. And then we call the pass file from autoparser and see if it returns an arrow, then it must some must be broken, and it's likely the injection broke that. Not, then we return null. So, and we could also from the pass we could check if, for example, if just kind of innocuous string, if it doesn't break, but the something with with the curly brackets breaks, or with the given injection, then it must be bad. So some of results that we reduced the false positive rate in the scanner to near zero, to almost zero, and that was a big relief both for us paranoids who have to deal with the output and tried this, and also the developers and QAs who use this. And it's still finding the real issues as we check with the WebSec lab. Also improved output because we can take the relevant parts from just not from the context, like the previous context part that of the breakage. The scanner with context detect was able, actually is now part of the CD pipeline, and it scans all the sites that go from developers, all the websites that go out. So you can say that Go has a role to play in keeping security lots of Yahoo sites. For the scanner system, we also had the distributed system with web services interface and multiple redundant workers that actually do the scanning. So there's a web server that provides the web service front end, takes a request, and then multiplexes it to one of the workers. That part is also done in Go. And we use also the scan test, and once you work with Go, I actually found that it's convenient for the functional testing. So you do Go test and put a build block on the functional, and it's worked quite well. So some of the thought that with dependency management in a cooperation environment, of course, we have to pin the third-party dependencies. And personally, I would like to limit the code in my repository to my code, so that it wouldn't have like all dependent libraries locally. It's maybe necessary in kind of outside, but we have trust that our mirrors will not go down, or they have proper replication. And Go, this idea that there shouldn't be config files, but if we want to pin the third-party dependency, then we are willing to compromise on the no config files ideal. One of ideas or thing that we explored is using Android Wrapper tool. That's a tool for management a number of dependencies. So it requires a manifest, a default.xml. It specifies like the sources and the paths, and it fetches the whole projects. It can be used to lay out the workspace and map wrappers to the path. We used it for a few months, and so there are some advantages, like for example, default.xml introduce at a glance documentation, and it shows you all the dependencies in one place. And also our CD system has a nice feature that if the dependencies change in default.xml, then it rebuilds it triggers your build. It wasn't done for Go, it was done for Android libraries, but we reused it, and it came to be very useful. And now we are thinking about, so I like default.xml because then I don't have to invent or repo manifest to invent a custom format, um, uh, and it's something that some developers know already. They're thinking about like doing it, maybe generating automatically with Go list, so that then you can change only the like versions, put the revision if you want to pin certain libraries, and it can be also maybe filled by the CD system automatically. So the next steps expand the context detector and convert also to the full Go scanner. Currently, it's some of legacy pieces that interact with Go and share it with web security community to promote Go among security people. And also, I'd like to hope to publish the deadlink scanner. So in conclusion, we found that Go is excellent foundation for security tools, and also it's very stable for large-scale systems. So I like our scanning in CD system. It's been running for weeks, and I've been going like on vacation and sabbatical, and it was still running surprisingly stable. And my teammates also appreciate this. If sometimes people say that Go is boring, so I think it's one part where boredom or Go being boring is great when it operates and just runs and runs and runs. And there's a lot of room for innovation and potential for the collaboration of web security and Go community. So if you're interested in doing this, ping me or let me know, so maybe we can cooperate. Thank you. Questions? Yeah?
Slide 9, you talked about the Go routines and having an optimal performance at around 200 or 300 Go routines.
Mm-hmm.
Was that machine specific, or did you find that it's also for different systems?
I think it's DNS. It depends on the DNS servers.
If you use the glibc resolver, they have threading bugs. So if you use the pure Go, if you build your Go binary with netgo, use the pure Go DNS one, you can do as many as you want.
Yeah. So it has nothing to do with.
Okay, so I should try. So I try to rebuild it with
Yeah,
this.
the glibc bug is fixed in
I've seen it, yeah.
And what kind of bug is it?
It's, C programmers don't use concurrency much, so. No, I mean, like, there's really just a latent data race bug in glibc in the threading, so.
Well, why is the default?
So in Go 1.5, we're thinking of making it the default if you don't have a weird etc resolve conf and nsswitch.conf. So we're trying to detect like you're not doing anything fancy, and we don't really need the glibc one.
Why do you use glib for it?
Because unfortunately, distributions and operating system vendors cram a lot of smarts into glibc instead of putting it in the kernel or something. And so, for instance, on OS 10, if you have a firewall, you can't resolve DNS because it won't open the port to receive the UDP packet back. And so the glibc one bypasses the firewall. And there are similar stories on Linux.
Well, not glibc on Darwin.
libc, whatever it is.
But on Linux, we have to do it because a lot of like weird enterprises have like LDAP lookups or something, or like weird special policy for like how things work, but only at the libc level. So.
Okay. Sure.
You talked about the JavaScript to check your JavaScript breaking.
Mm-hmm.
But isn't that also pretty specific for the web browser to break on certain code and other web browsers to not break on certain code?
Well, the JavaScript is standardized. So when we're just checking the JavaScript, I think it's you could even like on the command in Node and JS, if JavaScript is malformed, then it's malformed. I think the way the browsers now pick up those script pieces because of the HTML5 parsing algorithm is relatively standard. So I think it's I think it works and it doesn't depend so much on browsers. So. But of course, for the scanning, there are two levels. One is just the simple HTTP, and the other is with the browser automation. That's a different story. So.